There is no initial osmolarity gradient in the kidney's interstitial fluid, where the osmolarity is identical to that of normal body fluids. The first step involves sodium leaving the ascending limb, either by passive diffusion in the thin ascending limb or by the NAK2Cl cotransporter in the thick ascending limb. Because the thick ascending limb is impermeable to water, water stays behind and the osmolarity of the thick ascending fluid decreases. Sodium is added to the interstitial fluid, increasing its osmolarity. This creates an osmolarity difference between the interstitial fluid and the thick ascending limb. Water diffuses out of the thin descending limb until the fluid there has equilibrated with the interstitial fluid. Once the descending limb has equilibrated, fluid from the proximal tubule enters, pushing the higher osmolarity fluid below it down the loop of Henle. The osmolarities of the fluids in the descending limb and the interstitium are again mismatched, causing water to leave the descending limb until the two fluids have re-equilibrated. You can see a corticopapillary gradient being generated between the fluid in the cortex and the fluid below. These two steps are repeated, with each cycle enhancing the gradient. Sodium leaves the ascending limb for the interstitial fluid, decreasing osmolarity in the ascending limb. The interstitial fluid osmolarity increases. Water diffuses out of the thin descending limb, increasing the osmolarity in the descending limb until it equilibrates with the interstitial fluid. Low osmolarity fluid from the proximal tubule pushes the fluid below it down the loop of Henle. Water leaves the descending limb to decrease interstitial fluid osmolarity and re-equilibrate. At its maximum, the osmolarity of the inner medulla is 4 times that of the cortex.